Imagine a world where the sun never sets, or a planet so dark it reflects almost no light, or a planet with ice despite scorching temperatures. Well, buckle up for our adventure as we discover 5 of the most terrifying planets in the entire universe. Number 5, Gliese 436b. This exoplanet is a hot Neptune that orbits very close to its star. Despite the scorching temperatures, it hosts a layer of ice due to the immense pressure, a bizarre characteristic that challenges our understanding of planetary composition. Number 4, TRES-2b. Known as the dark planet, TRES-2b reflects less than 1% of the light that hits it, making it one of the darkest known exoplanets. Its pitch-black appearance is eerie and perplexing, as scientists are still trying to comprehend the reason behind its extreme darkness. Number 3, PSRB 1257 plus and 12. The planets around the pulsar, PSRB 1257 plus and 12, roughly 2,300 light-years away, were among the first confirmed exoplanets discovered. The pulsar's radiation and the compact nature of its planetary system could create an environment bathed in intense radiation, potentially making life as we know it impossible. Number 2, WASP-12b. Dubbed the Death Planet, WASP-12b orbits extremely close to its star, causing intense heat. Its atmosphere is being slowly stripped away by the star's gravity, creating a tail-like structure trailing behind the planet. This environment is inhospitable and undergoing a dramatic process of disintegration, making it a unique but menacing celestial body. Number 1, Gliese 581c. This exoplanet orbits within the habitable zone of its star, making it a potentially habitable world. But it has some eerie aspects. Gliese 581c's tidally locked rotation could result in extreme temperature differences between its day and night sides, making habitability challenging. The potential for a perpetually scorching side and a permanently frozen side might make it unsettling for potential inhabitants. Ever wondered about stars that make our sun look tiny? What if I told you there are stars out there so massive they'd make our sun seem like a mere grain of sand on a beach? These colossal cosmic bodies redefine the term big. Buckle up for a journey to explore these colossal stars and behold their mind-blowing magnitudes. Number 5, RW Cephei. RW Cephei, positioned in the Cepheus constellation, is another colossal red supergiant star. Its enormity surpasses that of the Sun by approximately 1,435 times, portraying its monumental size compared to our average-sized star. The sheer scale of RW Cephei and its classification as a red supergiant signifies the later stages of stellar evolution, where stars expand dramatically before their eventual transformation. Number 4, Mu Cephei. Mu Cephei, also known as Herschel's Garnet Star, resides in the Cepheus constellation. This red supergiant boasts a size estimated to be around 1,260 times that of our Sun, showcasing the vast diversity among stars in the universe. Mu Cephei's designation as a garnet star is due to its striking reddish appearance, making it a notable and captivating celestial sight. Number 3, Betelgeuse. Betelgeuse, a famous red supergiant in the Orion constellation, stands out due to its brightness and enormous size. About 951,200 times larger than our Sun, Betelgeuse's size makes it a stellar giant, capturing the fascination of astronomers and stargazers. Its visibility in the night sky and distinct reddish hue add to its allure and prominence among celestial objects. Number 2, VY Canis Majoris. VY Canis Majoris, situated in the Canis Major constellation, is another red supergiant star. This colossal star is approximately 1420 times larger than our Sun, portraying an awe-inspiring contrast in size. Its immense size indicates a stage in its life cycle where it has expanded significantly, marking the latter part of its stellar existence. Number 1 UI Scuti. UI Scuti, a red supergiant, lies approximately 9,500 light-years away in the Scutum constellation. This colossal star is a staggering 1,700 times larger than our Sun in terms of radius. To illustrate its immense size, envision UI Scuti replacing our Sun. Its enormity would extend far beyond the orbit of Jupiter, making our Sun seem minuscule in comparison. Despite its tremendous size, UI Scuti's visibility to the naked eye is hindered by its distance and location amidst numerous stars within the Milky Way. Ever thought about other planets like Earth? Well, buckle up for an exciting journey. Today we're diving into 5 amazing planets that could be Earth's cousins in space, each with its own unique story to tell. Number 5. Kepler 452b. Imagine a planet similar to Earth, but bigger. Known as Kepler 452b, this exoplanet is about 1.5 times the size of our planet and is often referred to as a super-Earth. It orbits a star much like our Sun, lying approximately 1,400 light-years away from Earth. Scientists have found that it resides in the habitable zone, a region around the star where conditions might support liquid water, essential for life as we know it. Number 4. Proxima Centauri b. Orbiting the closest star to our solar system, Proxima Centauri is a rocky planet known as Proxima Centauri b. Roughly the size of Earth, it exists within the habitable zone of its star. However, Proxima Centauri is a red dwarf, which means the conditions on this planet might differ significantly from Earth due to its host star being cooler and less luminous than our Sun. Number 3. TRAPPIST-1 system. Imagine a solar system where 7 Earth-sized planets dance around a small, ultra-cool star called TRAPPIST-1. Located about 40 light-years away, these exoplanets reside close to their star, and some fall within the habitable zone. These planets are so close together that one could potentially witness their neighboring worlds' appearances, akin to our Moon. Number 2, Kepler 186f. Roughly the size of Earth, Kepler 186f is an exoplanet orbiting a star cooler than our Sun, situated around 500 light-years away from us. Scientists believe it could potentially have seasons and a climate reminiscent of our own planet. Positioned within the habitable zone of its star, Kepler 186f is considered an important candidate in the quest for habitable exoplanets beyond our solar system. Number 1. LHS 1140b. Discovered around 40 light-years away, LHS 1140b is over 6 times the mass of Earth. Positioned within the habitable zone of its star, this exoplanet has caught scientists' attention as it could potentially have a rocky surface and host liquid water. Researchers are eagerly studying LHS to unravel more about its characteristics and potential for supporting life. Ever wondered why the Moon looks so bright at night? Imagine if it suddenly disappeared. What impact would that have on Earth? Turns out, the Moon isn't just a glowing ball in the sky. It plays a vital role in shaping our planet's rhythms and tides. Buckle up for our journey as we reveal the mysteries and significance of our lunar neighbor. Number 1. Moon's formation. The formation of the Moon, known as the Giant Impact Hypothesis, is a fascinating story in the early history of our solar system. About 4.5 billion years ago, during a period called the Late Heavy Bombardment, a Mars-sized celestial body, sometimes referred to as Theia, collided with the young Earth. The impact was incredibly violent, causing intense heat and energy. The collision led to a tremendous amount of debris being ejected into space, some of which coalesced to form a disk of molten rock and dust around Earth. Over time, gravity caused this material to gather and form the moon. The early moon was much closer to Earth than it is today, and it was likely molten due to the heat generated by the impact. As it gradually cooled, the surface solidified, forming the features we see today, such as craters, mountains, and plains. One of the pieces of evidence supporting the giant impact hypothesis is the similarity in isotopic compositions between Earth and moon rocks. Samples retrieved from the moon during the Apollo missions showed that they have remarkably similar chemical compositions to certain rocks found on Earth, suggesting a shared origin. This catastrophic collision not only contributed to the formation of the moon, but also played a significant role in shaping the early Earth, influencing its geological and environmental conditions, and possibly contributing essential elements necessary for life to develop on our planet. The study of the moon's formation provides valuable insights into the early processes that shaped our solar system. Number 2. Surface temperature extremes. The moon's lack of atmosphere greatly affects its surface temperatures, leading to dramatic temperature swings between day and night. During the lunar day, which lasts about 14 Earth days, temperatures can soar to around 127 degrees Celsius, 261 degrees Fahrenheit, or even higher in direct sunlight due to the absence of an atmosphere to filter out the sun's intense heat. Conversely, during the lunar night, which also spans about 14 Earth days, temperatures drop drastically because there's no atmosphere to retain heat. Without insulation, the surface rapidly loses heat, causing temperatures to plummet to approximately negative 173 degrees Celsius, negative 280 degrees Fahrenheit, or even lower in some shadowed areas. On Earth, our atmosphere acts as a blanket, trapping some of the sun's heat and redistributing it, which moderates temperature extremes between day and night. The lack of an atmosphere on the moon means there's no weather, no wind, and no protection from the sun's radiation or from the cold of space during the night. This extreme temperature difference makes it challenging for equipment and technology to function effectively on the lunar surface. Number 3. Moonquakes. Moonquakes are seismic activities that occur on the moon's surface, analogous to earthquakes on Earth, but with some differences in their causes and characteristics. These moonquakes were first discovered during the Apollo missions, and they've been identified as a result of various factors. Some moonquakes are caused by the gravitational forces exerted by Earth. The gravitational pull of Earth on the moon creates tidal forces, causing stress and tension in the moon's crust. These shallow moonquakes usually occur closer to the lunar surface. Other moonquakes are believed to be caused by the moon's cooling and contraction. As the moon's interior cools, it contracts, causing the crust to crack and shift, resulting in deeper moonquakes. These quakes can happen several hundred kilometers beneath the surface. Moonquakes can be categorized into different types based on their origins, duration, and intensity. Some moonquakes are relatively mild, while others can be more powerful, registering magnitudes on the Richter scale that would be felt by astronauts and potentially affect lunar structures. Unlike Earth, which has a dynamic tectonic system with moving plates, the moon doesn't have active plate tectonics. Therefore, moonquakes are not caused by plate movements, but rather by these other factors related to the moon's unique geology and interactions with Earth's gravitational pull. Number 4. Slow rotation. The moon's rotation period and orbital period around the Earth are nearly synchronized, resulting in a phenomenon known as tidal locking. This synchronization means that the moon rotates on its axis in about the same amount of time it takes to orbit the Earth, approximately 27.3 days. As a result of this synchronous rotation, we always see the same face of the moon from Earth, a side known as the near side. The other side, which faces away from Earth, is often referred to as the far side or dark side, although it also receives sunlight. The term dark side is a bit misleading because both the near and far sides of the moon experience day and night just like any other celestial body. However, the far side was historically unknown to humanity until spacecraft exploration provided the first images in the mid-20th century. Number 5. Lunar dust and footprints. The moon's surface is covered by a layer of fine, powdery material known as lunar regolith. This regolith is composed of crushed rocks, soil, and dust created by constant meteoroid impacts over billions of years. Unlike Earth, where weathering and erosion gradually modify surface features, the moon lacks significant geological processes like wind or water erosion, allowing the regolith to remain relatively unchanged. Apollo footprints and tire tracks. During the Apollo missions, Apollo 11 to 17, astronauts left distinctive footprints and tire tracks on the lunar surface. The lack of wind and water means that these imprints, made by astronauts' boots and the lunar rover's wheels, remain preserved. The disturbed regolith retains the shape of these footprints and tracks, creating a historical record of human activity on the moon. Thank you for joining us on this space adventure. There's a universe of exploration ahead. Stay tuned and subscribe for new videos featuring Space 5.